2.8D, we're just going to continue with more proofs using wordy statements, and we're going to begin first actually with the 5-minute check. So we're working more with angle proofs, and the 5-minute check takes us back to prior to supplementary, complementary, and perpendicular. So these are an angle addition proof. Now you can tell, or what might give it away, is that there are no wordy statements here. And so anytime you have a proof that's dealing with angle relationships and there are no wordy statements, you probably want to start by labeling your parts and your wholes. So angle ABC and angle DEF, those are congruent, so we can go ahead and mark them congruent. And those are wholes because they make up more than one angle. So anytime it's multiple angles, that will be a whole. Angle 2 is congruent to angle 4. Now remember, you have to mark that differently. So I'll use a double arc. And those are single angles, so those are parts. And then we're trying to prove angle 1 is congruent to angle 3. So that is a set of parts as well. And you ask yourself, if I start at the whole, how do I get to the part? Do I add to get to the part or subtract to get to the part? So this, in fact, will be a subtraction proof. We will subtract. Okay? So we put in our given angle ABC is congruent to angle DEF. Angle 2 is congruent to angle 4. That's our given. And we can go ahead and put the proof in at the end as well. We're getting good at that, so we'll put that down here. Angle 1 is congruent to angle 3. Now, a couple things you can do from the beginning and from the end and is convert it to equality, because we won't be able to do anything with this unless we convert this to equality first. So I'm actually only going to convert this first piece because we're going to wait and use this piece a little bit later. So we'll convert this measure of angle ABC equals the measure of angle DEF. And anytime we convert from congruence to equality is always definition of congruent angles, converting. So we can do that here too at the bottom. If angle 1 is congruent to angle 3, and that's what we're trying to prove, we must first prove that measure of angle 1 equals the measure of angle 3. And then when we pair these two things together, at the end of the pairing, that's where we put our definition. Definition of congruent angles. So if that's all you can do, that's still better than nothing, but that's a good place to start. All right, so we don't have any wordy statements. If we're doing we the people eat pizza, there are no wordy statements, so we're out of that, okay? Now, the next thing we want to do is go to the picture, and remember there are 3 things we can find from the picture. We can either find vertical angles, which there aren't any vertical angles. We could find a linear pair, and there aren't any lines cut by an angle, so there's no linear pairs here, but we do have angle addition. So that's actually where we're going to go next here. So in line 3, we're going to take our 2 wholes. Remember, angle addition is whole equals part plus part, and whole equals part plus part. And we have to take those wholes. Now, if you labeled your givens with the wholes and the parts up here at the top, then you already know your wholes are A, B, C, and D, E, F. So we put one hole here, measure of angle ABC, and we put our other hole, measure of angle DEF, here. And then you look at the picture. Angle ABC is made up of angle 1 and angle 2. So the measure of angle 1 plus the measure of angle 2. And then DEF is made up of angle 3 and angle 4. The measure of angle 3 plus the measure of angle 4. Alright, so we have no wordy statements. We went to the picture. The next thing we're looking at is we know we want to subtract. So we've got these whole angles, okay? And the thing with these whole angles is before we can subtract, we're going to have to stretch them out into their multiple angles before we can take a piece away. So we want to stretch ABC out into 2 angles. And the angle addition step tells us that ABC is equal to 1 plus 2. So instead of writing ABC, we write the measure of angle 1 plus the measure of angle 2. And instead of DEF, when we stretch that guy out, DEF is equal to 3 plus 4, so measure of angle 3 plus the measure of angle 4. Oops. So when you expand a statement or contract a statement, that's always going to be substitution because you're looking at this angle addition and it's saying that ABC is equal to 1 plus 2. So we're basically putting 1 plus 2 in place of ABC, and then we're putting the 3 plus 4 in place of DEF. Okay, but you can remember anytime you expand angles into its multiple angles, that's substitution. So here we are, 1 plus 2 equals 3 plus 4, and here's where we need to get to. 1 equals 3. So we have a 1 on the left side. We do have a 3 on the right side. So we have to figure out a way to get rid of the 2 and the 4. Okay? Now, don't forget, there's still another given that we have not used yet. Angle 2 is congruent to angle 4, which is very convenient because that means if angle 2 and 4 are congruent, then we can subtract that away. But remember, you can't do that until you convert it first to equality. So the measure of angle 2 equals the measure of angle 3. So it would be okay for you to convert it in the second step here. It would still be correct. But since we're not actually going to use it till we get down here, oftentimes it makes more sense to wait to convert it to equality till we're actually going to use it. But either place is actually fine. Now if we know 2 is equal to 3, we get rid of the 2, we get rid of the 3. That leaves us with the 1 and the 2, sorry, this should say 4. That's why. We get rid of the 2's and we get rid of the 4's, I'm sorry, which leaves the 3 behind. And we get rid of it because we're subtraction. Okay, so line 6, what did I do? Line 6 is subtraction. Sorry about that. This one, angle 2 is equal to angle 4 is coming from here, should be definition of congruent angles. And then we subtract to get 1 and 3, and then we convert using definition of congruent angles. So that definition of congruent angles in this proof comes into play 3 different times. Once for the first given, once for the second given, and once to go back to the proof. So that guy's our friend. He helps us with a lot of steps in our proofs. Okay, so that's another angle addition proof, and then we're going to move back into the wordy statements, the other angle relationships. So we're still dealing with we the people eat pizza, and the we is the wordy statements. We have 2 wordy statements at the beginning, yay, so we can get rid of those. Angle 1 is complementary to angle 3. Now there's no way to mark that in the diagram because 1 and 3 aren't next to each other, so there's nothing to put in the diagram there. We also know angle 2 is complementary to angle 3, all in the same given. Now these each have their own wordy statement, so we know that complementary means they add up to 90. So when we undo this first wordy statement, we could say the measure of angle 1 plus the measure of angle 3 equals 90. And in the same step, we can convert this guy. The measure of angle 2 plus the measure of angle 3 equals 90. So that's a wordy statement, which remember wordy statements are almost always definitions. That's definition of, and just look for the word complementary. Definition of comp if you want. Okay, so that's wordy statements. Next thing we want to do is go to the picture, but there's no vertical angles, no linear pairs, no angle addition, which is okay because, so there's nothing in the picture, nothing. But we do have 2 things that are equal to the same thing because both of these lines are equal to 90 degrees. So that means we can throw the 90 out and set this first line equal to this second line. Measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. So basically what we're doing is taking this 2 plus 3 and putting it in place of that 90. So when we put that in place of that one, that would be substitution. Or anytime you find 2 things that are equal to the same thing and you throw out the common link, if it's equality, then that'll be substitution. If it's congruence, then it would be transitive. So here's where we're at. We can go ahead and put our proof in. Angle 1 is congruent to angle 2. And we, oops, you can't see it. And we know we're working in equality here. I put it way down there at the bottom. So let me move it up so you can see it. Angle 1 is congruent to angle 2. And that's incongruence. So we can go ahead and undo that one and write that inequality to help us get another step in here. Measure of angle 1 equals the measure of angle 2. So here's where we are. 1 plus 3 equals 2 plus 3. And here's where we're trying to go. 1 equals 2. So what's gone? The 3 is gone on each side. Easy enough. But remember, before we can take that 3 away, we have to state the obvious. The measure of angle 3 equals the measure of angle 3. And what is that reason? When you look in the mirror, that's reflexive. And now, since those are equal, we can get rid of them on each side, and that would be subtraction. And finally, when we convert back to congruence, that would be definition of congruent angles. Okay? So we continue to work with this. We, the people, eat pizza. It works every single time. And as long as you are following that, then you should be able to work yourself through the proof. There's this gap in the middle where we're not using this, but usually it's obvious like this, where you know what you're taking away. So if you can do the beginning and the end using we the people eat pizza, then there's just this tiny bit in the middle that you have to do on your own, basically. All right, on the back side, we've got angle 1 is congruent to angle 3. We should mark that. And go ahead and put that in. And we're trying to prove that angle 2 is supplementary to angle 3. So we do we, the people, eat pizza. We do our wordy statements first. Now there's no wordy statement at the beginning, but if you want to go ahead and convert that using your definition, we can go ahead and change that. The measure of angle 1 equals the measure of angle 3. And that is still a definition of congruent angles. And then we have this wordy statement at the end. Angle 2 is supplementary to angle 3. And we know that if they're supplementary, then they must add up to 180. So measure of angle 2 plus the measure of angle 3 equals 180. So that will still be a definition, because remember, the wordy statements are always definitions. And in this case, the word is supplementary. So at the coupling, at the end of the pairing, not up here at the beginning, but at the end of the pairing, definition of supplementary. Okay? So there's our wordy statements. Next thing you want to do is go to the picture. Now there are options here. Vertical angles. There are in fact some vertical angles in this diagram, but because of the angles that I have labeled for you, you couldn't say one and this guy that's not labeled are vertical. So we're not going to use any vertical here. There's no angle addition where we have two angles that add up to a bigger angle that's labeled. So the only thing left is a linear pair, and we do in fact have a linear pair because angle 1 and angle 2 form a linear pair. So from the picture, we can say the measure of angle 1 plus the measure of angle 2 equals 180 because of linear pair postulate. All right, so we've gone to the picture, and that's all that we can do. So here is where we are, and actually let's change this just ever slightly. Instead of 1 plus 2, let's say 2 plus 1, because now we can look at this statement. Angle 2 plus 1 equals 180, and angle 2 plus 3 equals 180. Okay, and the reason, if we interchange that, then we can see that the angle 2 is the same, the 180 is the same. The only thing that's changing is the 1 and the 3. And why can we put a 3 in here instead of a 1? That's easy, because they are equal to each other. So as long as they're equal to each other, that means they're interchangeable anywhere in the problem. So instead of angle 1, we are doing a plug-in step here. We are putting angle 3 in its place. So that actually jumps us all the way down to line 4, and that would be a substitution step because we're putting 3 in place of 1. And now it will say 2 plus 3 equals 180. So that's substitution. And then the final step is definition of supplementary. Okay? You still have this gap in here, but that's quite all right. No big deal. Last one, perpendicular, final one. We have 2 wordy statements. And oftentimes people think this one's not a wordy statement, but it is in fact a wordy statement, and it's a very special wordy statement. And we'll talk about why, but let's go ahead and write it in. Ray BA is perpendicular to ray BC. And what does that mean we need to mark in the picture? Ray BA is perpendicular to ray BC. That means we should mark a box in there. You can make it tiny if you want, large, whatever. And we'll go ahead and write the measure of angle 2 equals the measure of angle 3. Okay, so perpendicular is a wordy statement, and it's special because perpendicular takes not only 1, but 2 steps to get out of this wordy statement. The first step is always, if these 2 rays are perpendicular, then they must form a right angle. So this is the step that people often miss because they want to go straight to saying that it must equal 90. But the definition of perpendicular lines are 2 lines that form right angles. So you must state that it's a right angle first. So we would say angle ABC is a right angle. And that comes from this word or this symbol, perpendicular. So this is definition of perpendicular. Now this is still a wordy statement, so we have to undo it one more time. If something is a right angle, what do we know about it? We know that its measure, the measure of angle ABC, must be equal to 90 degrees. Okay, so perpendicular is a wordy statement. It always takes 2 steps to get out. Because when we convert it once, it's still a wordy statement. Convert it again, and now it's mathematical. And that's what we need. So the second reason is the pairing of the right angle and the 90. And so this is definition of a right angle. Okay? And it was always going to go in this order. Perpendicular, then right angle. Perpendicular, then right angle. The only possible change would be if it's at the end of the proof, you might have to work backwards. Alright, so as we move down here, we could go ahead and put in our complementary. Angle 1 is complementary to angle 3. I'm putting it all the way down here. Okay. And we can undo that wordy statement. That must mean that the measure of angle 1 plus the measure of angle 3 equals 90 degrees. And this, at the end of that pairing is where you put your definition. Definition of complementary, the end. Okay, so we have done the wordy statements. We, the people, eat pizza. So we did the wordy statements, check. Okay, now we need to go to the picture. So once anything that's in a wordy statement is not usable, that's why we have to convert it out. So really all we know right now is this, angle ABC equals 90. And we do know this other given right here, which we'll use in a little bit. Angle 2 equals angle 3. But if we go to the picture, remember we've got vertical angles, but in this case there aren't any vertical angles. We've got a linear pair, but there are no linear pairs. But we do have an angle addition, so I'm going to slide this back down. We have an angle addition, and there's actually a couple different angle additions. But the one we want to use is the one we're already talking about in this proof. So we could say angle, 2 plus 3 equals this guy, except I didn't label these 2 ends of the rays. So we want to try to stay focused on what it is we're talking about, and that's measure of angle ABC that we're talking about. So we'll keep working on that guy. The measure of angle ABC is made up of what 2 parts? 1 plus 2. So the measure of angle 1 plus the measure of angle 2. And anytime we do whole equals part plus part, that's always angle addition. Now, we've gone to the picture. That's the only thing we can find. So we move on down. Do we have two things that are equal to the same thing? Now remember, these wordy statements are no good. So we're really focusing on these two things. And we do have two things that are both equal to this angle, angle ABC. So they're both equal to angle ABC, which means we're going to throw that angle ABC out, and we're going to set these two leftover guys equal to each other. So the measure of angle 1 plus the measure of angle 2 equals 90 degrees. And anytime you throw out that link, if it's equality, it's going to be substitution. Okay? So, wordy statements we did. Picture we did. Then we found two things that were equal to the same thing, so we could come up with this new statement. Now here is where you have to think a little more. You have to think about where you are. Here we are. 1 plus 2 equals 90. Here's where we need to get to. 1 plus 3 equals 90. So you ask yourself, how are these two different? Well, angle 1 is staying the same. The 90 is staying the same. The only thing that's different is the 2 and the 3. And what allows us to interchange the 2 and the 3? Right here. We know the measure of angle 2 is equal to the measure of angle 3, and it's already been converted to equality for us. So we don't even have to do that. So actually, all we're doing basically is taking this angle 3 and putting it in place of this angle 2, and that's going to be line 6 down here. That's going to be substitution. So we're just putting that guy in place of the 2 to get 1 plus 3 equals 90. And if we know they add up to 90, then we know that they must be complementary because of the definition of complementary. Okay? So it's all about this guy. We the people eat pizza, and just working through each of those steps and linking up anything that you can. If you use this, these will be 10 times easier for you. And you can always come back and watch this again.